Hello everyone, welcome to DSA training. Today we will discuss about some more problems and see this is the statement given to us. What we have to find? We have to find sum of first n natural numbers. What is the input? Input is a non-negative integer and you have to output sum of natural numbers. So friends, you know that for solving a problem there are multiple number of ways. Some may be efficient, some may be not. Now for this method also, for this problem also there are three methods. Method 1, method 2 and method 3. We will discuss all of those three methods. First we will think about the brute force method. Means an easy one. It is the method even a child can do. It is okay. Let's discuss about it. So, what is the input we have to give? N. So let's take it. Note that they have given that it should be a non-negative integer. So we will use int as our input function along with our input function. So this will handle input and what we have to output sum of natural numbers up to n. So how can we achieve that? Up to n means for range, for example, up to n means if our n is 5, then up to n means 0. Should we consider 0? No. 1, 2, 3, 4 and 5. That means we have to take the for loop from 1 to 5, no, 6. Why? Because the second parameter of for loop is exclusive. That's why we have to take n plus 1. So let me take it. For I in range of, from where we have to start from 1 up to n means n plus 1. See, this is the basic problem everyone can understand. Means here if the input is 6, what are the I values? 1 2 3 4 5 and 6. That's it. And what we have to do before doing, we will initialize a variable called sum and give a value as 0, a starting value. Now we will iteratively update its value as sum is equals to sum plus I. That's it. Finally, what we have to do, we have to print the value of sum. Let's see whether it is running or not. It is asking for input. Okay, let's give 9. See, it is giving 45. How do it? 1 plus 2 3, 3 plus 3 6, 6 plus 4 10, 15, 15 plus 6 21, 21 plus 7 28, 28 plus 8 36 and 36 plus 9 it's finally 45. So completed. But see here in this small problem I want to introduce you to the functions. Why functions are written? They are written to achieve some particular task. Now in this function I am going to implement a function. Here what is our target? Our target is to find the sum of natural numbers. So I am defining a function called, let me define top of everything, def. What is def? Def is the keyword used to create a function. Def, and my function name is sum. Sum. Let's take it as add because sum is a built-in function, right? That's why add. What parameters we have to pass? N. And the implementation of this will be exactly this one. Let's copy paste here. Done. Oh, indentation mistake. Yeah, let's try it. But here we should not print sum because sum is the local variable of add. Rather than this, we can return sum. Sorry, we can return sum and we can print the result of add function means add of n. Here what I am doing, I am doing a function call, and what is the value of add of n? It is the value returned by the function. So sum is returned by this function and this sum value will be here and it will be printed. Let's check this one too. It is asking for input. We'll try 9 only again. So it is giving 45. Let's take small symbols like 2. So it is giving 3. Now it is a brute force. And what is the time complexity here? See, in question they have asked us to try an approach whose time complexity is order of 1. But see here, what is the time complexity? Can anyone guess? Yeah, the time complexity is n. The time complexity is order of n. Why order of n? Because we are using a for loop here. Yeah, how many times this for loop is executing? N times from 1 to n. That's why the time complexity is order of n. And what is the space complexity? Here we are just using a variable sum and n. So the time complexity will be the space complexity will be order of 1. Space complexity is less, but time complexity is order of n. But they have asked us to try order of 1. So let's move to second method. And what is our second method is using recursion. I have already told you when to use recursion and when not, but we are just here explaining recursion just to show you how it is done in different cases. So recursion means what? Calling a function itself again and again. So for this purpose, for recursion, function definition is necessary. I mean, it is the ultimate thing. It is the most important thing. Without function, we can never implement a recursion. So let's create the similar add function and the input is given as n. And here I am somewhere below I am asking the user for input. See here I am abstracting the logic into functions because in all platforms, coding platforms like Geeks for Geeks or either Lead Code or in any competitive examinations, they will ask you not to write the whole code outside the function. They will ask you to organize your code using functions. That's why I'm introducing functions in this class. Okay, input is given. Now what should we do? Call the function. Yeah, here this function will start executing. But it is a recursion. For recursion, there will be two cases. One is the base case and the other is the recursive case. So what is our base case? Our base case is if n is equals to 1, return 1. Yeah, because our starting is 1 and our ending is n. We have to find the sum of numbers from 1 to n. That's why our base case is 1. And what is the recursive case else? Here we can skip else too, it will still execute. Else return n plus add of n minus 1. I will also trace the path for you, don't worry. It is asking for input, I am giving it 7. See, the output is right, and again giving the input as 5. The output is right, giving 4. The output is right. Now let's trace this path. Yeah. So first my n is 5. I have colon. This is our stack in memory. I have called the function add of 5. Now what this function will call? This function will call is n is 5. Is n is 1? No, because our n is 5, right? So what should it return? 5 plus and add of n minus 1 means 5 plus n plus means 5 plus add of 5 minus 1 means 4. Now again add of 4 means function call. Is n is 1? No. So this 5 is here only. Now this function, I am talking about this function. Now I am going to talk about this function. What will be the output of this function? N plus add of n minus 1 means 4 plus add of 4 minus 1, it's nothing but 3. Okay, now 5 plus 4 plus add of 3 means what? Add of 3 means is 3 is 1? No, that's why it is 3 plus add of 2. Now what is the updated one? 5 plus 4 plus 3 plus a of 2 means what? N plus add of n minus 1. 2 plus add of 1. Now see, finally our our base case is attack. Add of 1 means n is 1, so return 1. So our output will be 5 plus 4 plus 3 plus 2 plus 1. After returning 1, this will be erased from memory. After returning 2, after calculating this 3 plus 2 plus 1, it will be removed. After calculating 4 plus 3 plus 2 plus 1, this will be removed. After calculating 5 plus 4 plus 3 plus 2 plus 1, this will also be removed. After returning the value of 15, this will also be moved from recursive stack of memory. So hope you have understood. So what is the time complexity of this? See, we are continuously recursing. Here the space complexity, the time complexity is order of 1 only. Why? We are executing a statement for one time only. Here, are we using any loops? Are we using any nested loops? No. That's why time complexity is order of 1. But still it is not the best algorithm because the space complexity here is order of n. Why it is order of n? I have just shown you, right? I have shown you a recursive tracks. How many spaces, I mean blocks of memory it is occupying? For add of 5 it is occupying 1 block. For add of 4 it is occupying 1 block. For add of 3, 2, 1 means for n is equal to 5 it is calling itself for 5 times. Means it is occupying 5 blocks at a time in the memory. That's why space complexity is order of n. Then what is the efficient approach? Of course, it is the formula based approach. It is the efficient one, formula based approach. See, this is the basic formula. We all know what is the sum of first n natural numbers. It is of course n into n plus 1 by 2. So again define a function, add of n, giving n as input, and what should we return? Return n into n plus 1 by 2. See here, we can't write like this. We have to place the multiply symbol. Okay, now we will take the input of then sorry, it's an input of and print add of n. Let's execute this. It is asking for input, right? 1.0 for 2, 3.0. It is giving us the sum as float. Why it is giving us float? Just do one thing. Place here int of and we'll get it as an integer. Let's see. 6. Yeah, we have achieved. And what is time complexity here? It's simply order of n because it is just performing one operation. And what is the space complexity? It is also order of 1. Okay, hope you guys now see the similar problem, fourth one. By the way, what is the efficient approach among these three methods? Of course, it is the formula based one. Now see the sum of squares of first n natural numbers. Here the same three methods we have to use. Let me pause for a while and start coding. The same, just we have to change one line. Let me copy paste this and change that one line. See, here what I have to do, sum plus I into I. I into I means what here I am using means rather than 1 plus 2 plus 3 plus and so on, what I am doing 1 into 1, 1 square plus 2 into 2, 2 square plus 3 square plus 4 square and so on. Square I can here I can also do like I power 2 means 1 square 2 square I power 2 and I into I are same, right? Now let's see. Here's 1, the output is 1, is 2, 2 square, the output is 4, 4 plus 1 square is 1, that is 5. Again run it, 3, 1 square 1 plus 2 square 4 plus 3 square 9, total 14. Now what is the recursive method? Same. Just let me copy paste the thing. See, these are the basic problems, right? Now what I have to do here, I have to I will mention parentheses in order to avoid the n power 2. That's it. Let's check this. Here I'll not change here 1 as 1 power 2 because 1 power anything is 1, right? So I will leave it as written 1. 4, the output is giving 3, the output is giving 18, 9, 6. See what it is taking. Let's run it again. 15, the output is giving but this is not right for a n values, bigger number of n values. If we have take millions or n value in millions or thousands or 10,000s, then we will be stuck. We will have a problem with memory, like memory out of memory, like that cases. And what is the formula for um, sum of squares? Yeah, it is obviously n into n plus 1 into 2n plus 1 by 6. Let's see. Here we just have to change the formula, right? N into n plus 1 into 2n plus 1. Can we write 2n like this? No, we have to write 2 into n plus 1 by 6. Run it. 2. Hey, here it is saying there is a type error. What is the type error? Int object is not callable. Let me remove this, and the whole thing was a single. Let's see again. 3 n into n plus 1 into 2n plus 1 by 6. Let's do it again. Type error. And where is the type error? Int object is not callable. Int object is not callable. N into n plus 1. Yeah, into. I have missed into here. Now it will give us the right thing. See, these are the small mistakes we will encounter. And here it is giving float. Do the same thing, like put int function to convert from float to integer. See, it is giving me the output. Let's run it again. It is giving me the output. And what is the time complexities? Time and space complexities are the same as the above. Order of 1, sorry, time complexity order of n, space complexity order of 1. Time complexity order of 1, space complexity order of n. And here time complexity is 1 and space complexity is also 1. So thank you guys. Thank you for your valuable time, and I am signing